Okay, so my talk today, for lack of a better title, is OS 10 for the iOS programmer. I think in the last 5 years, we've seen a huge influx of Objective-C programmers, but 99% of them are doing work on iOS, and OS 10 is sort of this other thing that a lot of them have never touched, but there's actually a lot of interesting things about OS 10. So I want to sort of talk about how you can go from being just an iOS developer to being an iOS and Mac developer. And this is the list of things that I want to cover today. So why OS 10? Why should you care about OS 10? We kind of all know how big of a market there is for iOS developers and iOS apps, and why is OS 10 also important? And then I want to talk just a little bit about the history of OS 10. I think talks like this are sort of well informed by history. It's not technical, but I find it interesting. And then I want to sort of go through broad differences from iOS. So these are sort of high-level things you need to know about and think about when you're making the transition to doing desktop apps. And then some specific stuff. So I'll talk about specific APIs that are similar and different on OS 10, and what to look out for, and how to get started. And then finally, I gave it its own bullet point. I'm going to talk about Cocoa bindings, which is one of those technologies that's on OS 10 that's not on iOS at all. And we'll get into that later. So first of all, though, I kind of wanted to find out how many of, so I'm assuming everyone here is an iOS developer. Is there anyone that's not an iOS developer? No, I'm saying just you do iOS, doesn't do iOS at all. And how many people have done Mac OS 10 development? Well, it's actually a good number. I'm actually a little surprised. But and so how many have not done any Mac OS 10 development? Cool, a lot of you. So I was thinking about this question, why OS 10? Well, my background is that I was doing programming for Mac OS 10 before there was such a thing as iOS, and so I really came at this whole topic from the other perspective. I went from OS 10 to iOS, but I've actually sort of stuck with it. So I've done a lot of iOS development, but I still make my living doing Mac development mostly. And why have I stuck with it? Well, there are a lot of reasons, but I think one big one is that the kinds of problems that I want to solve in apps that I build, they often sort of require some of the things that Macs are still really good at compared to iOS devices. And the iPhone 5S is showing that this is sort of quickly changing, but Macs still have much more powerful hardware than an iPhone. You have maybe like an order of magnitude more CPU power on a Mac than you do on an iPhone. And that enables you to do some things that are just difficult to do for performance reasons on an iPhone, or on an iPad for that matter. Another thing is Macs have big screens, so you can fit a lot of stuff in an app on a Mac screen. Well, 11-inch MacBook Air is sort of a different story, but some Macs have big screens. And then I think maybe the most fundamental thing is that Macs and OS 10 have hardware keyboards, they have mice or trackpads, and it's really a kind of a different way of interfacing with the user. And I think we all know that for a lot of things, touch is really great. Touch has enabled user experiences that were really not possible before iOS and that are really good, but there are still things that touch is not the best at. You don't want to enter a lot of data on a touchscreen keyboard. You don't want to, you can't do really precision work with your fingertips, right? So if you're, in Photoshop or something, trying to do really precise work, touch is not great for that. We've come up with ways to make touch interfaces that actually let you do sort of some of that stuff, but it's still not as direct as a mouse. So that's something that I like about Macs. Another thing that's maybe minor is Macs have big hard drives. So if you've got an app that needs to deal with a lot of data, like a whole database of music or video editing or big photo libraries, Macs are good for that. And then I think maybe the thing that's most interesting to the technical mind in all of us is the APIs and frameworks that are available on OS 10. And that's what I'm going to spend most of the time talking about today. There are a lot of things that are still easier to do on OS 10 than they are on iOS in terms of APIs and frameworks. There are also plenty of cases where the opposite is true, and I'll talk about that too. iOS does make some things easier. And then I think this is kind of not something I had really planned to talk about, but several of the presentations this morning have reminded me that even though iOS is a huge, huge market and the iOS App Store is full of 1 million apps and 60 billion app sales, there's a lot of money to be made on the Mac. The average selling price of a Mac app is, well, if you were at the last talk upstairs before lunch, we saw that the average iOS app price is like 19 cents, and the average Mac App Store app price was $22. So you don't have to sell nearly as many copies of a Mac app to make the same amount of money you would make on iOS. So smaller market does not necessarily mean less profit for you. And I think another thing that was raised in that talk is this idea of considering cross-platform solutions. And Paul actually talked a lot about this in his talk on day one. Part of day one's success is that he's got a Mac app that people can use sitting at their desk, and then he's also got an iOS app so they don't miss out on things when they're mobile. And there's still a lot of opportunity for Mac and iOS apps that work together, that sync through iCloud, that sort of provide differently optimized experiences depending on where the user's using them. I think that sort of covers why I like OS 10, why I think it's still interesting to design for, or to develop for. So if you've done iOS development, you've never done OS 10 development, well, you probably all know this, but OS 10 and iOS are siblings. They're really not so far apart. I actually think it's probably more appropriate to say that they're parent and child. And it's not like you're going from doing iOS development to doing Android or something crazy like that, which I haven't done, so I can't really speak to it. But you're still writing Objective-C. You're still using Xcode, an interface builder, and instruments. And many of the frameworks are exactly the same, as I'll talk about in a minute. And even the things that are different are, more similar than they are different. So that kind of leads me into a history when I said they were siblings. So this is sort of a brief timeline of OS 10. The first version of OS 10 was actually a public beta that Apple charged for, which I think is kind of an interesting idea to charge for your betas. But they did that in September of 2000, and I think it's kind of infamous for being pretty rough. It was definitely beta quality. And they released the first real public version a few months later in the spring of 2001, and that was called Puma. Trivia question, does anyone know the name of public beta, 10.0 public beta? It's a weird one. No, it's Kodiak, so it's not a cat name. But they didn't use that in marketing materials or anything. In fact, I'm not even sure they started using cat names in marketing materials until 10.3 Panther. No, I guess Jaguar. They had the spots on the X, so that was in 2002. Anyway, they've released an upgrade every year, every 2 years since then, and that's not really the whole story. OS 10 has a lot longer history than that, and it really is sort of. So the story is Steve Jobs started this company called Next after he was kicked out of Apple in 1985. And they were a hardware company. They made computers, but they also made this operating system called Next Step, and they used a language called Objective-C, which was still fairly new at the time. And it was not theirs. They didn't invent Objective-C originally, but they used it, and they created this really great object-oriented toolkit for writing graphical user interface applications. And at the time, this was released in 1988, was the first version. That was really a cool new thing. It was informed by Smalltalk and the work Xerox had done, but as far as like a real thing that you could go out and buy and sort of had commercial applications, it was great. And so they kind of kept on with that. Hardware didn't really work out for them, and in 1993, 94, they stopped making hardware, and at the same time, they did this thing called OpenStep. So OpenStep was essentially their next step operating system with the kernel removed. It was the stuff we know today as Cocoa and Foundation and the developer tools, without the specific stuff for their operating system. And that was a partnership with Sun. And anyway, they turned into a software company. In 1996, Apple, had a real problem with their next generation operating system. They had this project going on for a long time called Copeland. It was not really going well, and they started looking for outside help. After considering a few other companies, they bought Next, and that brought Steve Jobs back to Apple, and I think we kind of all know the rest of the story. But what it means is that OS X is really a fusion of Next Step and the classic Mac OS. And at this point, it's really more like Next Step than it is like the classic Mac OS. And so OS X's history and Cocoa's history goes back a lot longer than even just 2000. It goes back to 1988. And I have a point with all this, but I'll get to it in a minute. In 2007, I guess I have that on the last slide, the first iPhone was released, and then a year later, in 2008, we got the first public SDK and the ability to start writing iOS apps, and you all know the story. But I think maybe what you don't know, if you haven't done Mac development, is that iOS was kind of Apple's chance to start over. So they had, at this point, 16 years of experience with these frameworks and this language and these tools, and they kind of knew what they would do differently if they did it again. And it was also a chance to not have to deal with a lot of legacy stuff and to be able to really kind of modernize the whole SDK. And they did that. So that's actually what accounts for a lot of the differences you see in iOS and OS X, where you might otherwise expect similarity. So don't be surprised if when you're starting OS X development, there are these sort of weird things that don't, like, why is it done this way? It's different than OS X, and I'll talk about some of these later. It's because there's this long legacy behind OS X, and it means there are some parts of it that are kind of old-fashioned and a little bit annoying, but it also means it's really mature. So OS X, iOS 7 has this new API called TextKit, which is a really great way to deal with richly formatted text and text editing. OS X has always had that. It's not new. So, and there are still other areas where iOS has not quite caught up. And so there's a lot to recommend OS X and the AppKit SDKs or APIs. I made this slide that shows all the frameworks that are shared between OS X and iOS. I just think this is kind of interesting. So those lists are the same on the left and right. Now, the misleading thing about this is some of the frameworks on OS X are actually a lot more powerful than their counterparts on iOS. For example, Core Image on OS X lets you write your own image filters. So if you're doing image processing on iOS, you've got Core Image and you've got a lot of really great built-in filters. But if you want to do something different and write your own, well, you can't use Core Image to do it. On OS X, that's not true. You can write your own Core Image filters that do whatever you want. Same sort of story with Core Audio, where on iOS you have Core Audio, and you even have audio units that are built in, but on OS X you can write your own audio units. And that's actually something that the apps that I work on make heavy use of, so it's important to us. IOKit is another example. So IOKit is not really I don't know of good uses for it in iOS as a public framework. On OS X, it's a public framework where it allows you to access hardware, and you can do all kinds of access to hardware, including USB, FireWire, different kinds of custom hardware. So it's pretty interesting. So that's a bunch of frameworks. I added the frameworks that are only on iOS, and you can see the list is getting longer. And this is a little bit out of date. I haven't updated it for any of the new stuff coming out because there are still NDAs in effect, but it would change a little bit, but not a lot. And that's the list if you show everything OS X has and iOS doesn't. So I think it's kind of striking. It's a little bit misleading because, like more than half of those frameworks I've never even heard of, but there's weird stuff in there like PCSC. Well, who knows what that is, TCL and TK. Well, I'm never going to use those. I know what they are, but I'm never going to use them. But there are some that are actually kind of interesting. Like one is SpriteKit, and you guys have maybe heard about SpriteKit. Sorry, not SpriteKit, SceneKit. SceneKit came out in 10.7 Lion a couple years ago, and it's a framework that lets you render and animate 3D scenes, 3D objects, using a purely Objective-C API that's really well designed. I care a lot about how the APIs I use are designed, and SceneKit is awesome. It's really cool. It's not on iOS. Maybe it will be someday, we don't know, but for now it's only on OS 10, and it's really cool. There's also some more obscure stuff, like there's Scripting Bridge, which I've used, that lets you control control other applications via AppleScript using Objective-C in your application, which is cool. You can use it to script iTunes or something if you want. There are other way more obscure ones that I haven't used, but like there's force feedback framework. So this allows you to hook up joysticks. I'm a hardware engineer, so this kind of stuff's interesting to me, but you can have joysticks that give force feedback, rumble or push against the user, that kind of thing. I mean, it's sort of something used in games, but it's cool. And then one that I found going through this list that might have been relevant, 6 or 7 years ago, not so much now maybe, but it's still there, is the DVD playback framework. So if you want to play DVDs in your app, there's a framework for that. So all that's interesting. That's kind of technical details. All these frameworks or whatever, but at a higher level, you really need to talk about some of the differences in the overall philosophy of the two platforms. And so I like this picture. It shows Keynote on the Mac versus Keynote on an iPhone. And you see on the Mac I obviously I set this screenshot up to look a certain way, but there are 6 windows open. And on the iPhone, it's not a window, but the full screen is taken up by Keynote. And even just that full screen is much simpler than the main Keynote window on the Mac. And I think many of the differences in the APIs and also the architectural choices you will make when you create a Mac application versus an iOS application are driven by this difference in user interface paradigm. So iOS only has a single screen of content visible at a time, basically. I mean, you've got popovers and things, but in general, the philosophy is one screen of content at a time. On OS 10, you can have as many windows as you want, and you can have a lot of content in a lot of different windows, and multiple apps on screen at the same time. And we talked already a little bit about touch versus mouse and keyboard, so that's another thing to think of. On OS 10, the whole way your user is going to interact with your app is a little different than with touch, and so you need to think about those kinds of things. A UI that works really great for touch on iOS is probably not what your users expect to see on OS 10, and vice versa, of course. And so you need to think about that when you're designing your user interface. I think it's important when you're kind of going through this process. Say you've got an iOS app that you want to port to the Mac. You want to create a Mac version of it. Don't make it look like you're like an iPhone screen in a window. Unless that really makes sense. For a Twitter client or something, maybe it makes sense. But you should make your app be a Mac app. Do the things the users expect. Learn and understand the features of OS 10. Learn and understand the conventions on OS 10. And use them. So you'll want to support keyboard shortcuts, the menu bar, full screen mode, multiple documents. Think about multiple screen support because a lot of Mac users have 2 or more screens. And you should also think about specific Mac technologies like AppleScript, Automator, menu bar icons. So a lot of apps they'll have an icon in the menu bar so that you can quickly access them. Spotlight plugins, if you've got custom content that Spotlight should be able to search, quick look, making use of the dock well, the services menu. There's kind of a long list, and I'm not saying include all of this stuff in every app you make, but you should just know about it, and if it makes sense for your app, use this stuff. And the last thing is, after this is all said and done, it kind of gives you this idea that the typical Mac app is probably going to be more complicated than the typical iOS app. That's not meant to scare anyone off, but it's just something that you should understand. Mac apps are bigger, tend to be bigger and more complicated, and take longer to develop than an iOS app. And there are some other reasons for that too that we'll talk about. But in some ways, Mac development's harder. In some ways, it's easier. So I prepared this. This is actually an app I worked on. It's a mix and key app called iMashup, and I cheated a little because we didn't go from iOS to the Mac. We went the other way, but I think it still illustrates the point. This interface was entirely designed for touch. So we've got big buttons up at the top, and not very many of them. I know it looks like there's kind of a lot packed in on the screen, but really not very many of them. We redesigned the interface. Even though the interface in the middle, as you'll see in a second, looks the same, it's meant to be used with a finger, so you don't need as much precision for tap targets and that kind of thing as you do at clicking on OS X. And the whole thing is simple and small, and it'll fit on an iPhone. And this is the Mac version that we came from. And I didn't cheat too much on this one, so I've only got one project open. But it actually will support multiple projects open at the same time, and you can copy and paste between them. You can do that kind of thing like you would expect. We support, the whole audio engine is written in Core Audio. We support custom audio unit plugins, so users can get plugins both from Apple, which there's a bunch that ship with the system, but also third parties. And in the audio world, there are a ton of third-party audio units for doing all kinds of effects and processing that they can use in their app. And then, of course, we also support bigger projects. You can have, instead of just 2 tracks, like in the iOS app, which was a decision made not because of the UI so much as because iOS device performance was not really good enough for us to do more than 2 on the 4S, which is what this was developed for. Here we have an unlimited. It's not unlimited, but it's 20 or something like that, because the CPUs in Macs are capable of that. So that's just sort of meant to be an example of how an iOS app and a Mac app should really fit the platforms they're on. All right, so I want to get into a little bit of technical stuff because I know that's why you're all here. It's fun to hear about code, right? I made this list. This is not meant to be exhaustive. It's just meant to be some of the really common things that everybody who's done any iOS programming has seen all the stuff on the right, and anybody who's done OS X programming has hit into and used the stuff on the left. And I want to talk about how they compare. So on iOS, you have this thing called, I probably should have flipped these around, but on iOS, you have this class called UI window. And what is UI window? Well, UI window is a top-level container class that represents the window on the screen. But on iOS, you really only have one window on a screen at a time. And for that matter, one window per app. If you're supporting multiple screens, like a projector or whatever, you'll have another UI window on the other screen. But most people probably don't deal with that. So on iOS, UI window is nothing, right? Nobody really does anything with UI window except occasionally setting the root view controller or something. On OS X, it's a little different story. NS window is actually kind of an important class. You use it much more frequently. But it does what it says. It represents a window on screen. It's also something the user will interact with. So you have the close, minimize, and zoom buttons. You've got a full screen button, et cetera. Resizing. That's all handled by NS window. And so this is something you need to know about. But it's not horribly tough or anything. Just know that that's actually a class that matters on OS X. And then on OS X, you have this thing called NS window controller. And on iOS, I said, well, it's like UI view controller, kind of, because UI view controller on iOS is the most important class in UIKit, right? But I'm not saying NS window controller is the most important class in AppKit, but it's the thing it's the controller for a single window on screen. So it handles loading the window up from a nib file, et cetera. You can subclass it, put your own code in there. Anyway, it kind of is like a UI view controller, but kind of not too. NS view and UI view, that's actually kind of easy. Those are actually fairly similar. So NS view is the thing that draws something on screen, but there are also some differences that are important. I think one thing is that, like I was saying before, iOS is more modern. UI view on iOS, I've got a fly buzzing around my ear. UI view on iOS, all UI views on iOS have a corresponding CA layer, core animation layer, and that actually enables a lot of nice behavior on iOS. So it's part of it's obviously the animation system on iOS, but it also lets you do things like easily change a layer or a view's background color, or you can set an image on a UI view's layer without even, it doesn't even have to be a UI image view, right? You can just set an image on it, things like that. On OS 10, by default, NS views do not have core animation layers associated with them. And it also means they're not very customizable just with methods on NS view. Now you can make your NS views have a layer. You call this method called set wants layer with yes, and then the view will have a backing layer. You still don't have those top level methods for customization. So what that means is that in an OS 10 app, if you've got a lot of custom UI, you're going to be subclassing NSView or NSView subclasses a lot more than you would on iOS. And I'm not just talking about custom interaction. Like, even if you just want to make a button that looks different than a default button, you're going to subclass NS button. I'll talk a little more about that later because there's some more to that. But NS View Controller is a class on OS 10. It's kind of like UI View Controller, except that NS View Controller on OS 10 only came out in 2007 with 10.5, and therefore it's not really like this first-class citizen where the whole framework is sort of built around NS View Controller. In fact, you can write an entire fully functional app without using NS View Controller at all. It doesn't have nearly the amount of functionality or responsibility that UI View Controller on iOS has. It's kind of basically just for loading views from nib files and dealing with some of the memory management related to that. But with all that said, I lately have been using NSView. In the Mac apps I've developed lately, I've used NSView Controller a little more like it's used on iOS. So in general, every sort of top-level view in my app does have a view controller. It makes it easier to separate out functionality that's logically unrelated. It also allows me, I like Interface Builder a lot. I know there are people who do everything in code. I'm an Interface Builder fan. But I can separate out views that really don't belong in the same nib into different nibs, just like you would do on iOS. Of course, the difference is I have a lot of those views on screen or even in a single window at the same time. Unfortunately, NS View Controller does not have the containment, the UI View Controller containment support. NS View Controller doesn't have that. So you can sort of add your own, kind of, if you want, but and I sort of do that, but it's not built in. I think that sort of covers NS View Controller and UI View Controller. NS Scroll View and UI Scroll View, there's not a lot to say about that, but they're pretty similar. I mean, they accomplish the same objective. NS Scroll View allows you to scroll an NS view, and UI Scroll View allows you to scroll UI views. The APIs and the architecture of those have some differences. I think the short answer is that NS Scroll View is not quite as nice to work with as UI Scroll View, but you're not going to be like completely confused. They're pretty similar. UI Table View and NS Table View, those are both really important classes on their respective platforms. Every iOS app has UI Table Views in it. I'm not sure every Mac app has NS Table Views, but a lot of them do. And they're actually pretty similar in terms of API. NS Table View has an NS Table View delegate and an NS Table View data source with methods that will look familiar to you coming from iOS, but NS Table View is quite a bit more complicated. It's also more flexible and more powerful in some ways than UI Table View. It lets you can have multiple columns. The columns are rearrangeable and resizable. You can sort. There's built-in support for sorting, that kind of thing. And it's all keyboard. It can be keyboard-driven. That's all. That support for keyboard. Like you type a few letters to automatically go to a certain row. That's built in. So it does some nice stuff. I didn't really know how to describe NSCell to an iOS developer. If you've done Mac development, you know what NSCell is. If you haven't done it, it's like NSCell is one of the biggest WTFs for an iOS developer coming from OS 10. It's the only thing I can think of. It's a big part of the drawing and event handling architecture in OS or in AppKit UI, but it's basically obsolete. The only reason we still have it is because we've always had it. You know, it's a legacy support thing, and there's good reason why we don't have it on iOS. I'll talk about that in actually some more detail later on. But just know that you're going to run into that. It's going to confuse you, and it's not actually that confusing once it's explained to you, I hope. CA layer, there's not really a lot to say. Those are actually very similar on both platforms. There are minor differences in the API. One thing that is interesting is that NS views can be layer backed, which is sort of like UI view on iOS, but they can also be layer hosting, which is where they don't have subviews, but they do have a hierarchy of sub-layers. And I'm not really going to talk about that, but it's out there. So you can have a view that's just displaying raw CA layers in a hierarchy but it does not contain subviews. NS responder and UI responder are similar. The responder chain on OS 10 and iOS is very similar, but the thing that I think is one thing that's kind of a gotcha is that NS view controller is not in the responder chain on OS 10. So if you're used to being able to have event handling methods, a responder, methods sent up the responder chain handled in your UI view controllers, you can't do that in your NS view controllers on OS 10. Well, or you can, but you're going to have to figure out how to do it yourself. NS window and NS window controller are in the responder chain. Well, NS window's in the responder chain. NS window controller is not just by itself in the responder chain, but if it's the delegate of any delegate of NS window is in the responder chain. And often that'll be an NS window controller. These are just a little more detail on NS view and UI view. Layer backing is optional. On UI view, you've got a lot of customization options. You basically subclass and override draw rect in NS view. One little thing is that on OS 10, the coordinate system's flipped compared to iOS by default. So on OS 10 in an NS view, the bottom left is 0, 0, and on iOS it's the top left. Sorry, top left, right? But you can flip. You can make views on OS 10 so they have a flipped coordinate system. So it's possible actually to make your views the other way on OS 10. And then of course input handling is different. NS view can handle mouse, keyboard, and touch events on iOS. UI view basically just handles touch events, right? Well, I mean there's keyboard support, but normally you're just dealing with touch events. All right, back to this. I don't think a presentation about OS 10 development for an iOS developer is complete without some discussion of NS cell. So what is an NS cell? Well, in the early days of Next, or not even the early days, but all the days of Next computers, a high-end machine might have like 32 megabytes of RAM, and the CPUs were a lot slower than they are today too. And so you didn't want to have really complex view hierarchies or be like churning through views, creating views and destroying them a lot, because that was going to take up a ton of memory and a lot of CPU time, and performance would be bad. So NS cell is this way to get around this that Next came up with, and it's an example of the flyweight pattern, which is probably a design pattern not a ton of you have heard about, but it's in Apple's Cocoa design patterns document. But an NS cell is just a lightweight little thing, and really all it knows how to do is draw something. It doesn't have a lot of state. It doesn't have all the overhead of NS view. It just kind of knows how to draw something on the screen. And so what happens is NS views in OS 10 use NS cells to draw their content. And I think in particular, it's true of basically all of the built-in classes like NS button and NS table view, and it's hard to rattle off classes off the top of your head, but it's basically obsolete because CPUs really are fast enough now, and we have plenty of memory, but I mean even on an iOS device, but they've always been on OS 10, and so they're still all over on OS 10. I wanted to show how NS table view uses NS cell, because this confused me when I started Mac development, and I think it confuses a lot of people. But if you were coming from iOS, you would think, well, each cell in this table is a view, right? I mean, that's how it is on iOS. But no, the whole table view, it's a little more complicated than this, but the whole table view is one view. And each cell is drawn by that view using an NS cell. So you've got this table view. it's actually a column. Each column has a cell that it uses to draw. And so at draw time, this is draw time, draw rect is running. That's a cell object. It draws that row, then it draws that row, then it draws that row like this. So it's the same cell, kind of like a rubber stamp drawing every row. It's not separate views for each row. What that means is that you can't, NS cell is sort of not, doesn't have a ton of state. You don't want to assume what you would assume if you had a single view for each row. Now the lucky news is that, in 10.7 Apple added support for added support to NS table view for what are called view-based table views, and those work a lot more like a UI table view. They do use a view for each cell, and they don't use NS cell at all, except I think in the table header, but that's, so you might still run into it. But anyway, you have to enable that. So in Interface Builder, there's a drop down to choose whether you want your table view to be view-based or cell-based. Unless you have some really good reason not to, just use view-based table views. It'll be way closer to what you expect coming from iOS. It's got a lot more flexibility and power to do custom UI and animations and that kind of thing, custom appearance and animations. So use view-based table views, but don't be too afraid if you find cell-based table views, because they're still out there all over in existing code or whatever. Sorry, I didn't mean to back up through this, and I'm not a Keynote expert. So for more info, well, you're obviously not going to write down those links, but Mike Ash has a, Mike Ash, if you don't know him, has a blog called NS Blog that's a very technical blog about Objective-C and iOS and OS X programming, and he has a post called Custom NS Cells Done Right that talks about how to do custom NS cells the right way, or at least in his opinion the right way. But it's a really good resource for learning about that, because you will run into this. If you want to do a custom button, you can't just set some properties on NS button, and you can't even just subclass NS button. Well, you kind of can, but you wouldn't normally subclass NS button and override draw rect. You would actually subclass NS button cell and override the NS button cells drawing methods and do your custom drawing in that cell. So, for example. All right, so last topic, which is a big one, is cocoa bindings. How many have heard of cocoa bindings? How many have used cocoa bindings? It's like the same people who have heard of it, I guess. So cocoa bindings is a technology that was introduced in OS X 10.3 in Panther in 2003, so 10 years ago, along with KVO, key value observing. So everybody knows about key value observing. Well, key value observing is the basis for cocoa bindings, and I wasn't at Apple, but I've always assumed that KVO was introduced to support cocoa bindings. Cocoa bindings allows you to bind UI elements to model objects or properties in your model and not write any controller code. It means you cut out the middleman. So when a UI element is bound to a model property, and anytime the property changes, the UI element will change. So you can bind a text field to a string in your data model, and if you change the string programmatically, the UI, the text, not the UI, but the NS text field will update just automatically. You don't have to write any code to make that happen. And vice versa. If somebody types something into the text field, the property will be changed automatically. No code. So this sounds great. Well, it is great. I really like cocoa bindings. I know I'll get argument from that out of some people. I use cocoa bindings all the time. I like them, but they're not without their shortcomings. So I guess these are out of order now, but they're powerful. They're very powerful. There's a lot you can do with bindings without writing any code, but there are pitfalls. If you run into problems, sometimes it can be difficult to debug, and particularly if you don't really understand what's going on very well. And then there are things that you're not going to want to do, or you can't do with bindings only. You are still sometimes going to have to write code, of course. I think we would all expect that. And the only thing up there I didn't say is bindings are well supported on OS 10, so they're supported by pretty much all of the built-in UI classes. They're supported. Their interface builder has support for setting them up, and I'll show some of that later. They're not, I don't know what Apple's plans are, but as of now, they're well supported. When new things come out, they support bindings. So, decide if you want to use them. There's an argument to be made not to use them, but I really like them. They can save you time. So, quick. This is a class that you find a lot when you're working with bindings. It's not the only class that's out there to support bindings, but it's sort of the one I've used the most. I think I end up dealing with the most, so I wanted to talk about it a little bit. But NSArray controller is a subclass of NSObject controller. It's entirely meant to help you do bindings, and sort of does the dirty work when you're binding UI elements to an array in your data model. It's basically like a generic controller class. So it does a lot of the things that your controller would do in a table view controller, except you don't have to write any code. It's already out there, right? It's just an Apple class. It can deal with underlying insertions and deletions. Taking those up and updating the UI, and vice versa. You can actually hook buttons directly up to methods on it to do insert and delete and that kind of thing, and it'll update the model. It can handle sorting and filtering. So if you want to sort your table view or sort for any other reason, it can do that. Filtering is like search, right? So if you want to search a table, well, this will using NS predicate filter the objects in your underlying model and update the table. And another trick up NSArray controller's sleeve is that it supports core data. It knows a lot about core data. You can give NSArray controller an entity name, which is the name of the core data entity that you want it to manage in an array. You give it a manage object context via bindings, and it knows how to fetch from, insert into, and delete objects out of core data, or out of the managed object context. And as an aside, which I wish I could show this, and I know there's probably a good reason for it to be gone, but I just loved it. It was like the thing that made me love bindings, and it's gone now. Is that it's not a big deal, but in Xcode 3, you could actually make a core data model. In the core data model editor, you could drag that file right onto a window in Interface Builder, which back then Interface Builder was a separate app. It wasn't built into Xcode. Drag it onto a window in Interface Builder, and it would just create a basic UI with a table view and buttons for adding and removing, and a search box, and like sort of a master detail interface with text fields. It supported search and sorting and editing multiple selections. It was really cool because literally no code. Like create your core data model, drag it into Interface Builder, and you've got an app that works. It was kind of insane, but I mean, of course, you'd want to customize it. It didn't look very nice, but it was just this cool thing that they got rid of it. Xcode 4 dropped that, but it was an impressive Cocoa and bindings demo. So I think that covers NSArray controller. This is sort of like it's like the built-in generic table controller for bindings. I wanted to show an example of bindings. Demos are risky, so hopefully this goes well. And I don't even know how to do this because I think I got to turn on mirroring, right? Okay. This projector is a lot smaller than I expected, so Xcode's probably going to more than fill up the screen, but so I first have a simple, and please don't judge me on the way these apps look. I mean, let's be honest, they're just thrown together for this demo. They look like garbage, but they show the point. So this is an iOS app, maybe. We've got a couple text fields and a slider, and the idea is that you can enter a name into the name field and an age in the age field, and then the slider is also changing the age field. So I can actually run this on the simulator, and if I'm lucky, that is a huge You can tell I'm not an iOS developer. Yeah, there we go. All right, so we have Johnny Appleseed, and he's 25. And if I drag the slider, text field updates. If I enter a different age, the slider updates, right? So that's all there is to that app, right? It's pretty simple. The model class is this ORS person. It's just a person with a name and an age. It's pretty simple. And then this is the code in the view controller to do everything that app does, right? So we set up KVO on the person. That way, anytime their name or age changes, we can update the text field with their new. I gotta make this bigger, don't I? Somebody should have said something. Oh, that's kind of big. See how we do with that. All right. Well, okay. So we set up some KVO on the person. Anytime the name changes, we set the text fields text to the new name, and same kind of thing with the age field and slider. And then what do we do? And then anytime the fields are edited or the slider moves, we just do the same kind of thing. We pass the new value back to the person. None of this is anything you guys haven't seen before, and it's not horrible, but for this simple of an app, but it's code you have to write, right? Now on OS 10, that's not the right thing. I have the same app. It's an OS 10 app. Does the exact same thing. Drag the slider, age changes, enter a number in there, and well, I should enter a better number, but the slider changes, right? And actually, it changes while I'm typing. That's kind of cool. Okay, so how does this work? Well, we have same class, same ORS person class, and then instead of a view controller, I just put the code in the window controller, because like I said, window controllers are kind of like view controllers. That's all the code. So this is a convenience method. I probably should have left that out because it makes it look like there's more code here than there really is. And then the only other thing I do is just create a default person when the app starts up so that there's something in there. There's no code for updating those UI elements. And that's because there really isn't any. So like everything in Interface Builder, there's a completely programmatic interface for bindings. If you don't want to use Interface Builder, you can set it all up in code. I like Interface Builder. So this little, I don't know what that's supposed to be, like a knot icon? Yeah, that probably kind of sums up bindings. But that's the bindings inspector in Interface Builder. And when you click on a UI element, you'll see some options, some things in the list. The things in the list depend on which kind of, which class the object is. But basically, all of them have a value binding, and that's the thing you're going to use the most, probably. So how do we set this up? Well, we want to bind to the files owner, which is the window controller, and we want to bind to the person.name key path. So the files owner's person's name. That's it. Well, what about the age? The age field and the slider are a little more interesting because then you have two controls that are both hooked up to the same underlying model value. It's the same thing. You bind the files owner and age, and you just bind the slider to the files owner and age, and they automatically now are both in sync with the model. So if I make changes in code to the model, they'll both update. If I change one of them, the underlying model is updated, and the other one sees that and updates. So that's sort of basic example of bindings. Now, if I have time, I'm here till 2:30. Is that right? Okay. This is a little bit riskier because I'm going to actually do some stuff. So I have this other target that's a core data. Yeah, 407 days since Time Machine backed this machine up. I think they should just turn that off eventually. All right, so this is a core data app. This is just some stuff to handle saving the database when you quit. Then I have this database class, but that's really all it is. It's got a method to save, which I call when the app quits. And then it has persistent store coordinator, a managed object model, and managed object context. And if you've seen core data, or if you've used core data, you've of course seen all of those things. And that's all it has. Those are the only methods. There are some internal methods that are, just for set up private methods, but nothing that you actually need to use. All right, so we want to create a little UI. The screen is so cramped. No, it's. That's actually, let's see if I opened the wrong project, I think. Yeah, so that's the finished one in case I can't get this to work. All right, so we want to create a, I guess I should have showed you the model, but the model is the same thing, right? So now I have person in core data, and they have age and name properties, but it's core data. It's core data object instead of just a NS object subclass. Man, I need a bigger screen. All right, so I've got a window. I'm going to be quick about this, but I want a table view. I want, oh man, auto layout off. That was not a diss on auto layout. It was just I don't have time for it right now. And I want, let's have a, oh man, my spacing is horrible. Let's have a button to add and a button to remove. Hopefully yeah. And then just for fun, if we have time, we'll add a search field. Okay, I think I'm all right. This is, so we've got an add button. When we click that, we want to just add a new entry to our core database. Core data database, and search, does what it says, searches. So the first thing we need is, remember, NS array controller, because we have a table. It needs to be filled up from an array. So we have an array controller. We'll drag that over here, and then the first thing we need to do is set this array controller up. It has two modes. It can either just manage a regular Objective-C, an array of regular Objective-C class objects, or if you want to do core data, you can give it an entity name. And we'll want person. I always kind of forget, but yeah, I think that's all right. All right, and then, see, I did it right, yeah. All right, so all I did there was told it, no, this text field didn't take I just told it that the entity it's going to manage is, or the objects it's going to manage are person entities. And then in here, we've got a few bindings. Note there's not a value one, but the important one, the first important one is the managed object context, and we want to bind that to the file's owners. I think that's right. Yeah, because I think sorry. Can't remember if I put that on the, no, it's just on the app delegate. Don't do that. I hate when the app delegate does everything in the app, but this was quick and dirty. So we'll bind, one of the options in here is the app delegate, and then we'll bind to the database. And you notice it actually knows that, so it can complete for us, and we want to bind to the managed object context. And that's all we need to bind to. You could also, if you're not doing core data, you've got options up here to bind the array that the NS array controller manages to some, array property in your model, or set property. That's all we need to do in the array controller. So this is going to be our name column and our age column, and you actually bind the columns. This is different depending on if you're using an NS view-based table view, or view-based table view or a cell-based table view. This is a cell-based table view, which is the default. The difference is that in a view-based table view, you bind the entire table to your array controller. In a cell-based table view, you bind each column to the appropriate key path. So this one will be name, and this one will be age. And that's all we need to do. We've got this, well, this will become relevant later, but the create sort descriptor checkbox is checked by default, and we want that. All right, so now what about removing and adding? We talked about that. Well, all we have to do is actually hook this up to the add method on the array controller. And then for remove, we'll hook it up to the remove action on the array controller. And then last but not least is the search field. Here we're going to actually bind the predicate binding, because the search field is controlling a predicate in the array controller, and we just bind it to the filter predicate. We want this to be, we'll just have it search by name. You could actually set it up so it has a menu and can search by lots of different things, but it's all good. All right, here's where we see if it actually works, or if I screwed something up. Okay, it loads from disk on launch, so that's something I already had in there. So part of it's working. And if I click add, yeah, I get another row, and I can put another name and age in there, and hey, I got an exception. And you got to get used to that if you're, especially when you're new with bindings, but even if you're not new with bindings, exceptions are sort of par for the course, and it's one of the things people don't like about bindings. Oh, it's because I don't have a number formatter on my age column. Make it a slider. This is veering way off. Yeah, you could make that a slider. Slider, yeah, but I'm not going to do it. But the problem is I don't have a number formatter. But what I really, so it's a string. You know, it's a string in the text field. If you attach a number formatter to it, it'll convert the string to and from numbers. But we can just leave everybody at their defaults and see what happens. Now, if I search for Jane, hey, it only shows her. So, I guess I should show sorting. So sorting works. It works for age. It would be more interesting if they weren't 2 zeros, but. And then, of course, it's core data. So this is not bindings, but it's all persistent. That's the demo, and that's the presentation. So.